Hello students, good evening and welcome to this live webinar. Okay, so what I'm going to do is let me just bring this thing, just give me 1 second. Yeah, so welcome to this live session for probability. This is a 10th standard class for probability. What we are going to be doing is a little bit like a revision, for the exam also. So we are going to be covering some the types of probability questions that you will get, and hopefully do some practice questions which will help you, address and do problems in the board exam. Now, before I go into the session itself, what I wanted to do is I wanted to share with you that we have created a revision course for the 10th standard students. This you can you can talk to any of the mentors and get this course. But I just wanted to share a sort of glimpse of what is there inside the course. So one of the things that's there inside is like, a section on probability, right? And so we have looked at the different types of questions. I'm not going to be able to do all these types today because that's going to take a lot of time. But just to give you an idea, see in what all is there in probability, right? First, the basics of probability, very, very important that everybody knows this. Probability of any event is the number of outcomes favorable to E by the number of all possible outcomes. Okay, this is the basic idea, and this is the one formula that's going to be applicable everywhere, right? Okay, next, the important thing is that 0 less than or equal to probability of E less than or equal to 1. This is always true. Okay, next, so what are the different types of problems? Card-based problems, right? So you have a deck of cards, 52 cards, right? And you know that the 4 suits are spades, clubs, hearts, and diamonds. And the cards are from ace till king, right? And so each suit has 13 cards, right? And problems based on this are very common, right? From 2 till ace are the different cards, okay? There are 13 cards, okay? Next, other direct applications, like it may involve dice or like calendar, dates, or like a factory with products. So all these different kinds of examples there, lucky draw. Okay. Then indirect applications where you are given P of E and you are asked to find P of E bar. Okay, that is 1 minus P of E. Okay, or you have to find some things related to area and all that. There you may have to apply indirect this thing of probability will come. You cannot just count number of outcomes by total number of possible outcomes. You'll have to do different kind of ideas there, right? Or like given the probability, find the number of favorable outcomes. Okay, or like, so in fact, yeah, the area question is that if you throw something on this rectangular field, what is the probability that it will land on this circle? Now, this is not, you cannot count number of favorable outcomes. So P of inside circle, you will do as area of circle by the area of the rectangle. Okay. Now, so this is all one skill builder in the sense that this is all the skill builder on basics of probability. So this is one skill builder. Okay, but it's also like an intro to the class for you to know what are the different types of questions that are there, right? Then we have multiple trials or categories. So objects of different colors, that's very important. You have blue colored balls, black colored balls, red colored balls in the bag, and then you have to pick something, right? Then the most important thing is multiple coin tosses or card picks, right? 2 coins are tossed, or 3 coins are tossed. What is the probability of getting at least 2 heads, etc.? Or you have 20 cards, you pick 2 cards. What is the probability that something like that? And then very important thing is throwing 2 dice. Okay, so these are different types of questions which each of these has been dealt with in detail in the revision course. Okay, I'm one of the teachers for the revision course, and probability chapter has been covered by me extensively. I just wanted to give this as a thing. Just give me a moment. Right before we just start the class itself. Okay, but there's also like an intro to the class where we know what are the different types of things that will come in the just give me a second. Somehow the screen is not sharing. Yeah, okay. So we do have a worksheet. Just give me 1 second. Okay, I don't know if you all have access to the worksheet. Let me just quickly confirm that with the mentors. Even if you don't have, there is no problem. I will. Okay, so there are some questions from this. Okay, okay. So what we will do is, okay. So I will start with question 5. So the order in which I was saying card-based problems, right? The basics of probability. Okay, the order in the questions is something that's not this thing. So let's say you have to draw a card at random from a well shuffled deck of 52 cards. Find the probability that the card drawn is a queen of hearts and is not a jack. Okay, please go ahead and do this question. Okay, just using the basics of probability idea, that is the probability of an event, okay, is the number of outcomes favorable to E. This is what we saw. Probability of event E is number of outcomes favorable to E by the total number of possible outcomes. Okay, there is a small catch here which I will explain later, but right now you can go ahead and do question 5. Okay. Okay, most students have got this right. Very, very good. Okay, so the answer here is not very difficult at all. See, you have 52 cards. So the total number of the denominator is 52. The total number of all possible outcomes, right? So if it's worth writing this formula every time, right? In fact, in the CBSE, you will probably be expected to write this, right? And what is the numerator? The number of outcomes favorable. So part one, if you want Queen of Hearts, there's only one outcome. So P of Q Hearts is 1 by 52. Okay. Next, it is not a jack. The probability that the card drawn is not a jack. How many jacks are there? 4, one from each suit. So not a jack will be 48 cards. So probability of not a jack, the number of outcomes favorable to that is 48. Total number of outcomes is 52, which becomes 12 by 13. Okay, this is, I think, fairly easy. But see, many of the questions here, they are actual board exam questions. You may find them easy, but the point is just to sort of revise and get some idea, right? And get some clarification, why this, why not that, etc. Right? Now, okay, one thing that you have to understand here, which we did not mention while doing the thing, is that the total number of possible outcomes has a small caveat, which is that before possible and outcomes, we must add the phrase equally likely. Now, why is that the case? Because, for example, for the second part, okay, I could technically do either a card is a jack or not a jack. These are the only possibilities. For every card, I can say it is either a jack or not a jack. Therefore, P of not a jack is equal to half. Why? Total 2 outcomes and favorable is 1. So what is wrong with this logic? This is clearly wrong. Now, CBSE or board exam is not going to ask you this question, but many students think of this question. Okay, so this is an extra okay. Okay, for this extra question, can somebody tell me, can give what the answer is? Okay, so many people have said, sir, you have not looked at 4 jacks, etc. But that's not the correct this thing. The correct objection to this method, see, this is not going to be asked in your board exam. This is not important from the board exam perspective, but for you to understand, correct objection is the two outcomes, jack and not a jack, are not equally likely. Therefore, you cannot apply the probability formula at all. Probability formula is only applicable when the denominator is the total number of equally likely outcomes, possible equally likely outcomes. So this is a subtle idea, okay, which many people miss, and in their head, and especially when we come to 2 dice, 2 coins, etc., this will become very important. Keep this in mind. I'll come back to this later. Okay, so that is what is wrong, and this is also an important foundation for 11th standard probability. Okay, understanding this properly, which a few people, not many, okay, Priscilla, Mariam, Tejas, okay, these are among the few students who have pointed out that the flaw is that they are not equally likely. Okay, now let's do some of the other questions. Okay, please go ahead and do question 1. Okay, Nimra, Alima, then Karthikeyan S. Okay, they've also got it right. Amit has also got it right. Okay, quite a few people have got this right. Okay, so we don't know the number of tickets she bought. Total number of tickets is 6,000, and of course the probability is the number of outcomes favorable by the total number of possible equally likely outcomes. Here, the equally likely outcomes are each of the 6,000 tickets So this is our assumption. It's not stated explicitly, but this is a fair assumption. Now, if the girl bought, let the number of tickets bought be n. Now, that means the number of outcomes favorable to winning is n, because each of those n tickets are likely has the same chance of winning. So the probability of winning is equal to n by 6,000. So 0.08 is n by 6,000. So n is 6,000 into 0.08, which happens to be 480, which many people have got right. Okay. Question 2. Please go ahead and do question 2. Okay, again, quite a few people have got this. Okay, so what are all the perfect cubes between 1 and 100, both included? Because the cards are numbered 1 to 100. Okay, so 1 itself is a perfect cube, which is 1 cube. Then 8 is 2 cube. Then 3 cube is 27. 4 cube is 64. Now 5 cube, if you look at it, is 125. And we cannot include 5 cube. right? So there are only 4 perfect cubes. Therefore, the probability of perfect cube is 4 by 100. Why 4 by 100? Now, each card is equally likely to be picked. Please remember the formula for the probability thing. Okay, we should always keep this in mind. The number of outcomes favorable to E by the total number of possible equally likely outcomes. So this denominator is 100 because each card 1 to 100 is equally likely to be picked, and then outcomes favorable is 4. So this is 1 by 25. Okay. Okay. If you have any doubts so far, I hope the questions have been very, very easy. Okay. Go ahead and do question 3. See, after that, the questions will be slightly tricky. Some of the questions, because I want to finish those also. We have only 1 hour. Okay. See, this should be very straightforward. This is just a direct 1 mark formula application, but it's an actual board exam question. So I thought I should just share it. Okay, now at this point, if you have any doubts so far, now slightly harder questions are going to come within the next 2 minutes, 3 minutes or so. So we are going to look at some harder questions. Okay, but like I said, the revision course has a very extensive collection of questions, 3 questions in each category, and including direct, indirect, all the different types of questions, area type questions, everything is there. Okay, so I would really recommend, and it's not just for this chapter, like that it is there for all the chapters, all the 15 or 16 chapters. Okay. Okay, this is fairly straightforward. It's a 1 mark question. P of E bar we know is 1 minus P of E. So P of not raining tomorrow is 1 minus P of will rain tomorrow. So it's 1 minus 0.85 is equal to 0.15. Okay. I hope this is clear. If any, 1 or 2 people made some silly mistakes, that's about it. Okay. If you have any other doubts or questions, okay, on what we have covered so far, Aparajit Bhatt, is this the same question from the course? No, the questions are different from what I maybe questions are not the same, but the what I'm talking about is that same skill builder course. Yes. Okay, go ahead and do question 6. Like for example, the question I've showed you and all is not there in the skill builder course. See, here you have to read through the whole thing. Okay, this question, quite a few people have made mistakes. Renu Lakshita, yes, sure. Why don't we do that also? Since you specifically asked, let's do one of those questions also. Okay, so this one, see, the question is, what is the probability that it is acceptable to Anmol? Now, Nigam will accept shares which are good, but Anmol, okay, will only reject shares which have major defects. Okay, so that means what? See, total number of shares is 60. Now, number of shirts with major defects is 8. Therefore, number of shirts acceptable to Anmol is 60 minus 8, which is 52. So you see, the point is, so this is the way you have to write so that you know, therefore, probability of accepted by Anmol is, 52 by 60, which is 13 by 15. Okay, the Nigam thing is completely useless, that information. But you have to read through it to understand that it is useless. Okay, so let me do an extra question since a couple of people have asked about it. Okay, so find the probability that a leap year has exactly 52 Wednesdays. Please note 52 is what I've asked. Okay, I don't think This kind of question has been directly asked, but why don't you go ahead and try solving this question? Okay, very few people have got the answer to this question. That much I can tell you. See, the question is, what is the probability that a leap year has exactly 52 Wednesdays? Okay, so first thing is leap year is 366 days. Okay, now if you look at day 1 to day 364, 364 is 52 into 7. Okay, so whatever is your first day, from day 1 to day 364, exactly 52 Sundays, Mondays, Tuesdays, everything will be there. Okay, exactly 52 Sundays, 52 Mondays, 52 Tuesdays, 52 Wednesdays, because 364 is divisible by 7. So from 1 till 364, no matter what the first day is, whether the first day is Sunday or Friday or Tuesday or Thursday, there will be exactly 52. Now the real question is, what happens on day 365 and day 366? Now, what are the possibilities for 365 and 366? Now, 365 can be a Sunday, in which case this is a Monday. This can be a Monday, in which case this is a Tuesday. Okay, so like this, you can do Tuesday, Wednesday, Thursday, Friday, Saturday. So this will be Wednesday, Thursday, Friday, Saturday, Sunday. Now, we already have had 52 Wednesdays here. Now, the question is, what is the probability that we have exactly 52 Wednesdays? Now, first thing is, each of these is equally likely. Each of these 7 possibilities for day 365 is equally likely. Now, and only these 7 are possible. Now, you may ask, sir, what about the 7 possibilities for day 366? The problem is, once you fix day 365, 366 is already fixed. There is no alternate. Okay. Now, of these, how many don't see? You want exactly 52 Wednesdays, but 52 Wednesdays have already happened by 364. That means these two are out. They are not favorable. The ones that are favorable are Sunday, Monday, Monday, Tuesday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. No Wednesdays. Okay. So number of possible outcomes is 7. Number of favorable outcomes, okay, which is number of outcomes with no Wednesday in days 365, 366 is 5. Because that's what is favorable. Why? Because we want exactly 52. The question says find the probability that a leap year has exactly 52 Wednesdays. Therefore, P of exactly 52 Wednesdays is equal to 5 by 7. And the following list of students got it right. Only very few students have got it right. Okay. So let me share their names on the screen. We have Vemuri, Atindra, Pragyan, Advait Jagdish, Jishnu, Nimra Alima, Vijayalakshmi Vaidyanathan, Kavya, Akshay Ganapati, R. Shravya, Tejas, Anilaj Nair, K. Prahaladavardhan, Amit, Purvika HM, Idaya, Kartikeyan S, and PRK. Maybe those are just initials. There's a spelling mistake. Please excuse me. Okay, congratulations to all the students who got it right. For the other questions, many more students got it right. Clearly, there is some confusion about the leap year question, which I hope has been cleared now. Okay, how to approach the leap year questions. Okay. Okay. Why don't we go ahead and do question 4 now? Please go ahead and do question 4. Okay, quite a few people have got the answer for this question. See, the jar only has blue, then black and green marbles, right? So let the total number of marbles be n. Now P of blue is equal to 1 by 5. So is equal to number of blue marbles by n. So number of blue marbles is n by 5. Okay. Now similarly, P of black is equal to 1 by 4. Number of black marbles is n by 4. See, 1 by 4 is 4 by, see, 1 by 4 is equal to number of black marbles by n. So number of black marbles is n by 4. Okay. Now, we know total is n. So n by 5 plus n by 4 plus 11, which is the number of green marbles, is n. So from this we can calculate. Okay, so this is 9n by 20 plus 11 is n. So n minus 9n by 20 is 11. So 11n by 20 is 11, which implies n is equal to 20. Okay. Hope this is clear. Okay. So another way to do this question, another way is P of green is equal to 11 by n. Now, a ball is either blue or green or black. Therefore, 1 by 5 plus 1 by 4 plus 11 by n is equal to 1. So this is one way to do. So this way, 11 by n is 1 minus 1 by 4 plus 1 by 5, which is 11 by 20. Another way is to say P of blue and green are 1 by 4 or 1 by 5. So P of not blue or, sorry, blue or black. Not blue or black is 1 minus that. That is the same as P of green. So all of these will give you the same answer. Okay. Okay. Now, questions 7 and 8 are important. So I want to take at least maybe 10 minutes extra, which I hope is okay. Okay, please go ahead and do question 7. Okay, we'll but since we are also near the end of the scheduled time, right? If you have any doubts so far, whatever we have covered, including the leap year question, okay, please do share. Okay. Okay, quite a few people got 20 correctly. So let me tell you some of the students who got exactly 20, who submitted the answers. Renu Lakshita, Abhinav, Diya Lakshman, Kavya, Shankar Venkatesh, Avantika Kumari, Diya Deepu, Nimra Alima, Kavishri, Akshay Ganapati, Vemuri Atindra, Dhairya Singh, Amit, Priscilla Mariam, Vijay Lakshmi Vaidyanathan, Advait Jagdish, Diya, Kartikeyan, Nandita, Aditya Narayanan, Sai Vignesh, Ritika Somasundaram, Shravya, Aditi Hegde, Maitri Das, Tejas, Gargi, Stavya, Srinidhi, Purvika, Sanjit, PR Case, Srishti, Aklam J, Ananya, Chiranjeev, Raghav, Tanush, Darshan, Aparajit Bhatt, Kavan, Nalina Raj, Jishnu, Dhanush, NM. Okay, so here this kind of question is where many students make mistakes. What are the possible outcomes? Okay, so 3 coins are tossed. Coin 1, coin 2, coin 3. One possibility is all are heads. The other possibility is first 2 are heads, this is tails. First one in heads, this is tails, this is heads, and heads, tails, tails. So you see, first I looked at coin 1, all heads. Then coin 2, heads, then tails. And coin 3, heads, tails, keeps changing. Now, the next is, of course, for coin 1, we'll put all tails. Okay, but for coin 2, we will start with heads and then end with tails. Here we will change heads, tails. So you see there are 8 possible outcomes. Okay, and at least one head. So let's outcome. 1, 2, 3, 4, 5, 6, 7, 8. Now, which outcomes have at least one head? All outcomes except 8 have at least one head. Therefore, probability of at least one head is equal to 7 by 8. The next is exactly one tail. Okay, the outcomes that have exactly one tail. Okay, you can see number 2, number 3, number 5. Okay, 3 by 8. And the third question is 2 heads and 1 tail. Okay, you might think this is very less, but actually you find 2 heads and 1 tail here. Number 2, number 3, and number 5. That's the same as exactly one tail. So probability is again 3 by 8. Okay. Okay. Now you go ahead and do question 8. That is the last question. Here, when you throw 2 dice, the most important thing is the list of all possible equally likely outcomes. This, if you understand, then the 2 dice problems become very, very easy. The list of all possible equally likely outcomes is to list all the pairs like this: 1, 1, 1, 2 till 1, 6, 2, 1, 2, 2 till 2, 6, like that, 6, 1, 6, 6, 36 possible outcomes. Once you understand this, question 8 becomes very, very manageable. Okay. Now, Renu Lakshita, I want to solve more leap year sums because that's where I lose marks. See, there aren't too many leap year questions possible. I just did some variation. I just came up with my own question. That exactly 52 Wednesdays. See, you have to understand that in leap year, the 364 days, there is no problem. Okay, the last 2 days is the issue. So there, consider all the possibilities. Avantika Kumari is also asking about leap year questions. Okay. Birthday on the same day, birthday questions, that is slightly difficult. I don't know how they will ask you the 2 people having the same birthday or something like that. Okay, but again, the same logic you have to do. Priscilla Mariam has asked about the difference between at least and at most. Okay. See, for example, when we said at least one head, at least means okay. See, at least 2 implies 2 or more. So 2, 3, 4, everything is okay. At most 2 implies 2 or less. That means 2, 1, 0. Usually negative is never there in probability. So this is the difference between at least and at most. Okay, I hope the difference is now clear. Priscilla Mariam. Okay, then Kaven has asked, what about card questions which has or, and, either or neither, etc. Okay. Okay, I will give an example. So see, for example, pack of 52 cards. What is the probability of picking a spade or an 8? So here you have to look at the number of favorable outcomes is equal to, or list of favorable outcomes. Forget the number. First, let's do the list. A spade, 2 spade, 3 spade, till king spade. 13 cards. Then 8 hearts, 8 diamond, and 8 clubs. 8 spade is already here. So number of favorable outcomes is equal to 13 plus 3, which is 16. This is the key. This is the kind of thing that you may have to be comfortable with, Kavin. Okay, now for question 8, we have quite a few people who have answered. Okay, how do you find the cases where the difference is 2? Difference is 2 means the 2 numbers. So list of possible outcomes. So you can do 1, 3 and 3, 1. Difference is 2. Then 2, 4 and 4, 2. Okay. Then you can have 3 as the smaller number. Okay. So 3, 5 and 5, 3. If 4 is the smaller number, 4, 6 and 6, 4. See, anything else, 5 and 7 is not possible. 5 and 3 we have already accounted for. Therefore, list of favorable outcomes, not possible outcomes. Is equal to 8. Probability is 8 by 36, which is 2 by 9. Okay. I hope this is clear. This also, we have Swati, Akshay Ganapati, Diya Dipu. Kavin got it but didn't simplify. Okay, Sai Vignesh, Kavya, Diya, Kavishri, then Shankar Venkatesh, Amit, Ananya, Tejas, Vemuri Atindra, Nimra Alima, Advait Jagdish, Dhairya Singh, Tanush, Stavya, Sanjit, Vijayalakshmi Vaidyanathan. Many people have got the answer. Most people have got it right also. Okay. Okay, so let's stop here. Okay. I hope this was useful. Okay, this is more like a revision rather than a class from scratch. Okay. I do hope you were able to understand a little bit of the different kinds of ideas involved in probability. Okay. So all the best to all of you. Okay, and I hope to see many of you as part of the regular AHA Guru classes next year also. All the best with your board exams too. Okay. Good night.